Hello, I am Sebai, Assistant Professor at INSAT and Image Processing Researcher at Crystal Laboratory at ANSI. I will present our work entitled MPEG-DASH Users Quality of Experience Enhancement for MOOC Videos that is realized by my fellow Emna Manei and myself. The plan of the presentation is as follows. I will first introduce the context of our work. Second, I will detail the proposed MOOC Videos Dash dataset. Third, I will present the results and discussions in terms of quality of experience. Finally, the conclusion and perspectives will be drawn. Being an efficient, attractive, and ludic means, videos allow improving the learner's experience. They also assist instructors to closely conform to innovative pedagogical approaches such as active teaching, flipped classroom, and e-learning. This even privileges the emergence of MOOCs, the massive, open, online courses. The interest of these latter is steadily growing in different learning fields, such as cooking recipes, movie making, sport, and computer sciences. Nowadays, the number of MOOC is considerably increasing in recent years, moving from 6,000 courses in 2017 to 12,000 in 2019. In the same context, Jeff Majoncalda, the Chief Executive Officer of Coursera, states that the MOOCs global market will move from $3.9 billion in 2018 to $20.8 billion in 2024. The display quality of MOOC videos depends on several factors. The most influential one is the streaming method. It's necessary to opt for a video streaming that considers the transmission network conditions, such as a bandwidth generally fluctuating and a bitrate commonly slow and unstable. This tends to avoid the classical streaming that steps aside in favor of adaptive streaming. In this context, dynamic adaptive streaming over HTTP MPEG-DASH is the most recent and used norm for adaptive streaming of video content. Using MPEG-DASH, the video stream is automatically adjusted to a low definition when the network is congested, which reduces the risk to the users to watch a frequently interrupted video. As depicted in this table, the main state-of-the-art MPEG-DASH datasets are -ITEC, -IF, and UHD HEVC. We observe the scarcity of content-oriented datasets and more specifically of MOOC videos-oriented datasets. Further, the number of videos per dataset is small. We also notice that none of the datasets provides a complete study of the display quality of the test videos. Existing datasets merely present dashified segments of videos at different bitrates without affording quantitative or qualitative evaluations of these latter. Despite that MPEG-DASH is considered a viable technology that efficiently ensures adaptive streaming of internet content, few research efforts have been made to investigate how to apply this relatively new technology on improving the quality of experience of MOOC video streaming. Three related work are synthesized in this present table according to their main features. Despite the diversity of the addressed approach, the main issue of all the state-of-the-art methods consists in enhancing the final learner's quality of experience during the MOOC's videos display. However, each of the related work focuses on one and only one MPEG-DASH parameter simultaneously, such as the segment duration, the video's content type, and the segment retrieval from servers. Proposed work treat all the MOOC's videos as being of the same content nature. It may, however, turn out to be necessary or useful to treat them differently according to their type. State-of-the-art work generalize the obtained results from the test videos to all MOOC's videos. However, the number of videos used to establish tests do not go beyond 4. Furthermore, the choice in these three methods does not consider the resolution and length diversity of MOOC's videos as well as the multitude of their learning domains. In this paper, we propose to enhance the learner's quality of experience while following MOOC videos. For that purpose, we propose to develop a set of dashified MOOC videos in order to present reference examples on which the concerned users can rely on in order to correctly validate parameters of their MPEG-DASH player without having to do the tests on their own so that they can save effort, time, and money. The dashified videos will then serve to handle a study in order to define the most adequate MPEG-DASH parameters per MOOC videos type. This will provide an upstream visibility of the adaptive streaming quality related to each type of MOOC videos. The content of the proposed MOOC videos dash dataset is summarized in the present table. Typically, we make use of 15 videos belonging to 5 MOOC videos types, namely slides-only videos, instructor-centered, combination of slides and instructor, motion videos, and mixed videos. For all these videos, we opt as codecs for the latest and the most commonly used compression standards, namely H264, H265, and VP9. For each codec, we envisage as bitrates 18 values ranging from 50 to 8,000 kilobits per second. For each of these bitrates, we consider 5 resolutions, and in order to create this content, we opt for the latest stable version of the FFmpeg tool. Once included, the obtained videos are subject to a dashification step that serves to produce their corresponding MPEG-DASH manifest files. For this, we use the MP4box tool. Once the dataset is constructed, our aim is to look for the most appropriate MPEG-DASH parameters for each of the above-mentioned MOOC videos types. Let's start with the compression standard. Here we look for the most adequate codec among H264, 65, and VP9 for MOOC videos. The present curves present the evolution of the MOS mean opinion score according to bitrates expressed in kilobits per second for the 3 codecs and for each MOOC video type. We typically opt for 15 observers to evaluate the quality of the MOOC videos. Based on obtained results, we observe that only H265 codec, the curve in blue, presents a good trade-off between complexity and ray distortion performance. Moreover, the complexity of VP9 makes it less used. Its coding time is in fact greater by a factor of 19.73% and 34.43% respectively against H265 and H264. These curves also allow us to determine the bitrate threshold value that leads to an adaptive MPEG-DASH streaming of good quality per MOOC videos type. We consider that the visual quality of a video is good if the MOS score assigned by the observers is greater than or equal to 4.5. The slides-only videos require a bitrate of more than 700 kilobits per second to guarantee visible slides and avoid unclear or illegible writing. Instructor-centered MOOC videos require a smaller bitrate of 500 kilobits per second in order to have a good video display. Here, the learner is not as demanding about the video display quality. The auditory information provided by the instructor is in support of the slides' written information and enhances the course understanding. Concerning the combination of instructor and slides, motion and mixed MOOC videos, the visual quality is consistently evaluated as good, very good, or excellent for bitrates greater than 800 kilobits per second. This is justified by the content heterogeneity as well as the rapid and frequent scenes transitions that occur in such types of videos. The following experimentations are carried out on network in order to consider the bandwidth fluctuations and be under near actual streaming conditions. The present curves depict for each MOOC video type the evolution of the MOS scores assigned by the 15 observers according to 5 segment durations, namely 1, 2, 4, 6, and 8 seconds. We observe that the display quality of slides-only videos evolves, reaching an average MOS of 4 for 4 seconds segments duration. Beyond that, the curve declines. This proves that the visual quality of the slides-only courses degrades as the segments duration increases. The learners rapidly note the distortion of the slides content given that the segments duration of the dashified MOOC videos are quite long. For instructor-centered videos, MOS scores vary slightly between 3 and 4 according to segment durations. These videos are actually limited to the only presence of the instructor, so the sharpness of the instructor voice and the clearness of what he says greatly help the learner to understand the course even at low display qualities. The motion videos content, such as demonstrations or illustrations, is suitably displayed to learners if the streaming is adapted to bandwidth constraints every 1 or 2 seconds. And for the two remaining types of MOOC videos, the shape of the mouse curve is irregular. The quality perceived and judged by the observers does not evolve in a stable and regular manner according to segments durations. To conclude, in this paper, we develop a content-aware dataset of dashified MOOC videos. It includes 15 MOOC videos that are of different characteristics and represent 5 different MOOC types. These videos are firstly encoded using the best state-of-the-art codecs, namely H264, H265, and VP9, then dashified according to a coding scheme of several combinations of bitrates and display resolutions. In order to enhance the learner's quality of experience, the so-generated MPEG-DASH manifest files and segments are subsequently exploited to study the most appropriate codecs, bitrates, and segment durations for each type of MOOC videos. As perspective to this work, we aim to integrate the 360-degree virtual reality videos to our set of MOOCs. These videos are increasingly used in the education domain, since the learner is totally immersed in his learning environment. Thank you for your attention. I remain at your disposal for any question, remark, comment, or discussion. Thank you again.